Write the set x such that x is a positive integer, x square is less than 40. हमने देखा था सेट्स को रिप्रेजेंट करने के दो तरीके थे, एक रोस्टर और दूसरा सेट बिल्डर। यहाँ पे क्वेश्चन सेट बिल्डर फॉर्म में दिया हुआ है, जहाँ पे क्वेश्चन को इस तरह से लिखा जाता है, ब्रैकेट्स के बीच में x such that x is a positive integer and x square is less than 40. So we are asked to write this in roster. तो सेट को हम कोई नाम दे देते हैं, जैसे हमने देखा था कि सेट हम हमेशा हम कैपिटल लेटर से सेट को नेम देते हैं, तो हमने इसको x नेम दे दिया एंड वी स्टार्ट विद द कर्ली ब्रैकेट and we write all the integers. Positive integer is talking about, so 1 2 3 4 5 so on, whose square is less than 40. So I see square of 1 is 1, so 1 will be a member of this. Square of 2 is 4. वो सारे नंबर जिनका स्क्वायर 40 से छोटा होता है, तो 3, you have 4, you have 5 and you have 6. हम 7 नहीं लेंगे क्योंकि 7 स्क्वायर 49 हो जाता है. That means 7 does not belong to this set x. यहां से हम इसको करली ब्रैकेट बंद कर दिया, तो ये हमारा रोस्टर फॉर्म और टेबुलर फॉर्म में आ गया. तो इस सीरीज में आपको क्वेश्चन ऐसे दिए रहेंगे, जहां पे आपको किसी भी सेट को रोस्टर से टेबुलर या टेबुलर से रोस्टर में चेंज करने के लिए कुछ सेट्स हमारे पास ऐसे होते हैं जिनको टेबुलर फॉर्म में नहीं रिप्रेजेंट किया जा सकता. जैसे अगर हम कहें रियल नंबर्स, तो रियल नंबर इतने सारे हैं और कोई डेफिनेट पैटर्न फॉलो नहीं करते, तो रियल नंबर्स को हम टेबुलर फॉर्म में नहीं लिख सकते, उसको हमें सेट बिल्डर फॉर्म में ही लिखना पड़ेगा. अच्छा, यहाँ पर एक और क्वेश्चन आता है कि सेट कौन सा है कौन सा नहीं है. हमने डेफिनेशन में कहा था सेट इज अ कलेक्शन ऑफ वेल डिफाइंड ऑब्जेक्ट. आई आस्क यू अ क्वेश्चन, इफ आई आस्क, वेल, कलेक्शन ऑफ 5 मोस्ट रिनाउंड मैथमेटिशियंस ऑफ द वर्ल्ड, क्या ये एक सेट है? अब देखिए, वर्ल्ड में बहुत सारे रिनाउंड मैथमेटिशियन है, तो हु इज मोस्ट रिनाउंड, दैट इज अ कंट्रोवर्शियल क्वेश्चन. एक वेल डिफाइंड ऑब्जेक्ट नहीं है, ये सेट नहीं होगा. सो मेरा क्वेश्चन था, कलेक्शन ऑफ द 5 मोस्ट रिनाउंड मैथमेटिशियन इन द वर्ल्ड, क्या ये सेट है? तो ये एक सेट नहीं है, नॉट अ. एक और एग्जांपल देता हूं, अगर मैं कहूँ कलेक्शन ऑफ मोस्ट सक्सेसफुल एथलीट्स इन द वर्ल्ड, दैट इज आल्सो नॉट अ सेट. आपके हिसाब से रॉजर फेडरर मोस्ट रिनाउंड एथलीट हो सकता है, पर किसी और के हिसाब से विराट कोहली है. तो इस तरह से हर एक पर्सन की चॉइस और वो के हिसाब, प्रायोरिटी के हिसाब से वो सेट चेंज हो जाएगा. कोई वेल डिफाइंड नहीं है. इस तरह के कलेक्शन वेल डिफाइंड नहीं होते, तो हम उनको सेट नहीं लेंगे. इसके बाद हमारे पास क्या है? नेक्स्ट जो हम सीखने वाले हैं वो है टाइप्स ऑफ सेट. इसमें जो पहला हमारे पास टाइप आता है, एम्प्टी सेट. एज द नेम सजेस्ट, एम्प्टी सेट. इस एम्प्टी सेट को हम और भी किसी नाम से जानते हैं, जैसे आपका निक नेम होता है ना, इसी तरह से इनका भी निक नेम समझ लीजिए या कुछ दूसरा ऑल्टरनेटिव नेम. तो एम्प्टी सेट आपके पास होता है, नल सेट भी इसको बोलते हैं. नल कुछ नहीं, एम्प्टी भी कुछ नहीं है, नल सेट. और यह इसको कई बार हम वॉइड सेट भी बोलते. तो a set which does not contain any element is called empty set. All right, और null set और void set. अब ऐसा भी सेट क्या जिसमें कुछ नहीं है, एग्जाम्पल के हिसाब से. अच्छा, इसको हम कैसे रिप्रेजेंट करते हैं? नल सेट वॉइड सेल को हम रिप्रेजेंट करने के लिए 5 से रिप्रेजेंट करते हैं. 0 लिख के लाइन ड्रॉप कर देते हैं, दिस इज कॉल्ड 5. और या फिर इसको हम एम्प्टी ब्रैकेट और सिंपली ब्रैकेट बना दीजिए और उसके अंदर कोई एलिमेंट लिखना नहीं है। तो ये दो तरीके हैं नल सेट को रिप्रेजेंट करने के। Let's see the example. The question says x is that 1 less than x less than 2 and x is a natural number. So in this, we all are very well familiar with real number line. So in the real number line, if I have some number, right? Here, suppose I have 0, here is 1, here is 2, and 3. These are the natural number and they will go on till infinity. Now he's asking find a natural number which is between greater than 1 and smaller than 2. So I cannot see any number here, which is a natural number. So this set will be a null set. So you also write this set as pi. So this is a set builder form. In set builder form, it is written like this. And in tabular form, roster form, I will write it like this. Next comes finite set. Here also, as the name suggests, a set which is empty or consists of a definite number of elements called finite set. All right. Now we can take the example. Z is the set of points on a line. So is this a finite set? How many points can be on the line? On the line, there can be infinite points. Actually, between any two closest points on the line, there are infinite points. So if Z is a set of points on a line, this will be the infinite set, right? Or now I have given another example. S is the set of solution to the equation x square minus 16 equal to 0. So when I solve x square minus 16 equal to 0, I get x is equal to square root 16, which is plus minus 4. So I get a set. If I write the set in tabular form, S will come minus 4, comma, plus 4, these two elements. So there are two elements, which is a definite number. So I say this is a definite set. So here G is indefinite set, whereas S is definite. So what we have next? Let's see. All right, after this, all infinite sets cannot be described in roster form that we just discussed a moment back. For example, the set of real number cannot be described in this form because the element of the set do not follow any particular pattern. See, the infinite set, sometimes they follow pattern. For example, when I say natural number n, say they follow a pattern 1, 2, 3, 4, 5, and so on. So I can write it like this. So set of natural number can be written in both set builder and tabular. But set of real number cannot be written in tabular form because of obvious reason. All right. So next we have empty set. Okay, equal set. When do we say the two sets are equal? So the two sets A and B are said to be equal if they have exactly same element, right? So A and B are equal when we are saying they are actually the same set, but we have just given them different names. So if I have a set A which contains element 1, 2, 3, I have another set B which contains element 2, 1, 3. Now see, the two sets apparently look different, but they are same. They have exactly same number of elements, and they are actually same element in the sets. So we say these two sets are equal. So actually, we have just written the different name. We can also say the both sets are equal. So we can say A is equal to A. Set does not change. So we have given these small points which the student basically miss sometime. Like we have given it hashtag. So a set does not change if one or more element of the set are repeated. That means as we have written the set A up there, 1, 2, 3. If I write a set B, which has the element 1, 1, 2, 3. So these two sets, though 1, 1 is repeated 2 times, so it does not change anything. So we take 1 as 1 time on these two sets are still same. Conventionally, we do not repeat any number in the set. Okay, what next? All right, so we will discuss about subsets. Now, to understand subset, consider two sets. So I give you set X, the set of student in your school, and set Y, the set of all students in your class. So set X is set of all student in your school. Set Y is a set of all student in your class. So what can I say? If a student belong to your class, does he belong to your school also? Yes, right? So we can say in this case, your class is the subset of your school. Similarly, class 10th is the subset of your school. Class 8th is the subset of your school. So how do we write Y subset of X? We write with this symbol, U-like symbol, and inverted horizontally, kind of. The symbol subset stand for subset. It means contained in. Contained. Set A is said to be subset of set B. Every element of A is element of B. If every element of every student of your class is also a student of your school, so your class is subset of your school. All right. So this subset, now we will try to understand mathematically the concept of subset a little better. In subset, what we do, we take a basic set, like your school is the basic set, and then you make classes of the different students, so they are the subsets. I give you one set rather, which contains element A, B, C. Three elements are there, and how many subsets are possible here? Let's see how many different groups we can make. See, what I can do is I can choose none of these three elements. So the set formed will be 5. So this is one of the subset. Now can take one element, any one of these three, single element. So I make these sets. And then I can take two elements and a set is made. Then I take B and C. Then I take C and A, two together. There are three combination possible. And then finally I write all three together, A, B, C. And I notice that there are 8 subset formed. If I have 3 element in my set A, then I'm getting 8 subset of that. Is there some pattern? How do we know how many subset will be formed? Yes, there is a pattern. We always see that when there are n element in set A, there will be, so how do I write it? I did number of element in set A is equal to, so let me say P. Then number of subset will be, number of subsets will be 2 to power P. If I apply the formula here I have 3 elements. So 2 to power 3, I get 8. There are 8 subsets. All right. So mathematically, we will write it like this. If A is the subset of A is the subset of B. If A belong to A implies A belong to B. Now you can take this example you can understand this example with the help of a student of your class and a student of your school. All right. So, we can say when A is the subset of B and B is the subset of A, then this is if and only if. See this sign we say if and only if A is equal to B. So A is subset of B means A contained in B, and B is subset of A means B contained in A. When is this possible? A contains in B and B contains in A when they both are equal. So it will imply A equal to. Next, here we have from the above definition, we see that A is the subset of itself. That's what it is. Since the empty set has no element, so we agree that the empty set is the subset of all sets. Okay. The empty set is the subset of set A. In regard to the set of the real numbers, like n is the set of natural number, z is the set of integers, we can say n is the subset of z and z is the subset of q. Q are the rational numbers, which includes integer and decimal fractions, and which is the subset of r. If I define t as the subset of uh, irrational numbers, then t is also a subset of r. As you know, under root 2 is irrational number, but under root 2 can be represented on the number, so which is a subset of. But the natural number is not a subset of t. Natural number does not contain in irrational numbers. So that's how we can understand the relation between. Here we have defined t as irrational number can be written in set builder form x such that x belong to R and x is not रियल नंबर है पर रैशनल नंबर नहीं है, तो इसको हम बोलेंगे इरेशनल नंबर। और इरेशनल नंबर हमने देखा इज नॉट अ सब irrational number is not a subset of real number. Irrational number is the subset of real number, but natural number is not a set of irrational. So next we have intervals of a subset R. So if you have any two numbers A and B on the real number line, say A is less than B, then the set of real numbers Y such that A less than Y less than B called an open interval noted by open interval AB. So you can understand it like this. So you have the real number line. So there is a number A over here and number B this side, and then the number increases both side, positive and negative side in the real number line. So if you are talking about the number which are between A and B, we represent it like this. Similarly, we can draw the diagram for this subset of the real number where the numbers are between A and B, but the A and B is also in. So this is how we represent this number. And next we can also write the number between, we can also say and define another set where the numbers are between x is equal to A. So for equal to, we will show the dark circle, and is not equal to B. So this number is B, here is A. So this is B, here is A. All right. So A, B, both are not included. And finally, one more set can be defined where A is not included, but B is included. So you can show the real number line like this, where A is not equal, here is the number A, and B is P is included in that set. Is written like this. Or so this is how we can represent a subset of real number. So the number between two given numbers in a real number line, and when the given number either are included or not. So we have these subsets, and after that we have next power set. Now we will quickly define power set. So what is power set? As the name suggests, all right, the number of, if we make a collection of all the subset of a given set, that is called power set, and we represent power set by EA. Now here, if I give an example of A is a set contains element A comma B, all right? So if I am asked to write power set of A, it will be a set of all subset. As we see the formula, we have already discussed it. This formula, if A is the set with NA is equal to M, means number of element in set A is M, then then NPA is 2 to power. Here I see the number of element is 2, so number of subset will be 2 to power 2. I know the 4th subset has to be there inside this. What I do, the pi is the subset of all right? So I write that, and then I take one element here, A, and then I take B, another element. So fortunately, I have just two elements, and it's easy to write A comma B. Otherwise, I will make all the combination which are possible. So this is power set. So understanding power set is also very very easy. That is number of. So we write all subset of the given set in, and we make a set out of those subsets, which is a power set. मतलब इस set A के जितने भी subset हो सकते हैं, उन सब को as an element लेके एक subset बना दिया. अब जो मेरा PA बना हुआ है, ये इसके element है. एक चीज यहाँ पे नोटिस करने की बहुत इंपॉर्टेंट चीज है ये, कि जैसे आपका A है, A बिलोंग टू A करता है, A आपका कैपिटल A में है, बट A आपका PA में बिलोंग नहीं करता. This is very important. This does not belong to A because I do not see A here. अब आप बोलोगे कि यहाँ A तो दिख रहा है. Now this is different from A because इस A के साथ ये brackets भी है. So what? You have this A belong to PA. But A does not belong to PA. Set A belong to PA. तो ये थोड़ा सा notice करने दीजिए यहाँ पे. All right. So next, let's see what we have. Power set and then यूनिवर्सल सेट. ये एक इंटरेस्टिंग चीज है. यूनिवर्सल सेट किसको बोलेंगे? जब भी हम सेट्स के बारे में बात कर रहे होते हैं या सेट्स के बारे में कोई क्वेश्चन डिस्कस कर रहे होते हैं, तो हमारे पास एक बेसिक सेट होता है और फिर उससे सबसेट के सबसेट्स के बारे में. तो बेसिक सेट हमारा यूनिवर्सल सेट है, एंड उसके बाद जो उसके सबसेट बनेंगे उनको हम ए बी सी कुछ भी नेम देते हैं, और उनका ऑपरेशन या उन पे वर्किंग हम समझते हैं. तो यहाँ पे हमारा कॉन्सेप्ट यूनिवर्सल सेट को समझना है. यूनिवर्सल सेट क्या होता है? इट इज अ बेसिक सेट, राइट? एंड द यूनिवर्सल सेट and usually denoted by U. So universal set is usually denoted by U. Now अगर हम इधर देखें, जैसे अगर आप एक छोटे से एग्जांपल समझ सकते हैं, अगर हम आपके स्कूल को यूनिवर्सल सेट दे देते हैं, so we will write it X such that X is a student of some school. Let me write the name of that school, of this school. And now all the subset like class 10, class 9, class 7, so they will be the subset of this universal